Hello, everyone. Welcome to iCast. Today we have a returning guest, Nicholas Rivadero. If you want to give an introduction to the people who haven't seen your first episode.
Yeah, so my name is Nicholas Rivadero, and I'm a Calculus 1, Calculus AB student, and I love math.
Yeah, and from his own self-study, he's way past Calculus 1, and I know that from personal experience
Yeah.
with him. And today we decided on a very cool podcast topic, at least for us, because we both come from immigrant parents. We are going to be talking about immigrants in the fields of sciences, and today we're going to be focusing on India. As you can see back there, we have one of the greats of mathematics, which Nick will be talking about, Srinivasa Ramanujan.
Right, so, okay, this might look a little bit daunting at first, right? We see an infinite series, right? And basically what this infinite series is just an approximation of 1 over pi, all right? So the reason why we hold Ramanujan as someone so special is because he was never formally trained, right? He sent his works of mathematics to England, where he was later discovered as one of the best mathematicians of history. And so the reason why this equation in specific is so special is because the story goes that it was written on his tongue in a dream, right? It might sound a little far-fetched, but that's what he believed and that's what he saw. And it turns out that infinite series is correct. So, yeah, it's pretty believable, I'd say.
I watched a movie, actually, and plus extra research, and I know he had a lot of cultural challenges moving from India to Great Britain. If you could expand a little bit on that.
Yeah, so, I mean, when he moved from India to Great Britain, he faced a lot of struggles, obviously, adapting to the food, and there was a lot of hatred at the time as well.
Yeah, of course.
As you referred to in the movie, right? Yeah, he faced a lot of challenges. There was a lot of bullying, a lot of hatred, a lot of racism.
Yeah,
right?
of course.
And that's what a lot of immigrants face today, obviously. Which is why I would say Ramanujan is a great representation of what many people face today.
Yeah, and who was that person in Britain who was able to bring him in?
Right, so the main person was D.H. Hardy, obviously, with Littlewood, with his partner, I would say.
Yeah, I think he was an assistant, but he was also a professor.
Yeah.
A fellow at Cambridge.
Yeah, exactly, yeah. So, D.H. Hardy saw his work. He was a little estranged at first. He thought, there's no way someone could come up with this and be right. You know, no proofs, no formal training. But in reality, he brought Ramanujan in, and he saw how impressive the works were.
Yeah.
And so he decided to teach Ramanujan everything there was to know about proofs. Ramanujan was a little hesitant. He wanted to come to Britain to get published, right?
Yeah.
But when G.H. Hardy told him he needed to learn formal proofs, he was a little hesitant at first. Which is where Ramanujan's thoughts on Britain kind of took a turn. But in reality, what sparked the majority of Ramanujan's fame is his work on partitions.
Yes.
So do you know a little bit about partitions?
Yeah, that's actually what I know him for.
Right.
Obviously, at the time, it was a very daunting problem. Definitely one of the top in number theory, along with prime numbers. If you want to explain a little bit about what he was able to accomplish there.
Right, so I'll start off with a little bit of the history of partitions, right? So partitions are just how many ways you can form a number. So let's say you have the number 4, right? And you want to arrange it in a certain amount of ways. So you can form it as 3 plus 1, 2 plus 1 plus 1, 1 plus 1 plus 1, 2 plus 2. And so those are the partitions, right? There's 5 ways of partitioning it because there's also 4, right?
Yeah.
So that's 5 ways, okay?
Yeah.
And what Ramanujan did was he came up with a formula to actually find what the partitions were for a certain amount of number. And what's impressive about the formula is that as we approach such a big number, the accuracy gets better and better.
Yeah.
So that's what's important about that partition formula.
And I want everyone listening to think about that fact for a second, because the fact that he's able to provide a formula where as we go to infinity, the error actually decreases down to 0.
Exactly, yeah.
I have never seen something like that in mathematics.
we can contrast it with obviously the prime counting function.
Yeah.
We know that as it increases, the error gets greater.
Yeah.
But that's what's so impressive about this partitions formula is that it gives you something with less error. You know?
No, and as you go to infinity, the way to think about it is really the higher number you go, the less error you're actually going to get for how close it becomes.
Exactly.
And the lower number you go, the more error is going to become.
Exactly.
And he was able to have a staple in mathematics with this partition formula.
And what's also impressive, this is a little anecdote that I wanted to include. was his findings on the number 1729. So do you know anything about that?
It's the anecdote with the taxi cab, correct?
Exactly.
Yeah.
So the story goes that when G.H. Hardy was visiting Ramanujan in the hospital when he had tuberculosis, that was another one of the adversities that Ramanujan faced. Obviously, it's the sicknesses that came along with coming to a different country, right?
Now, I could be wrong about this. Does he actually died of tuberculosis, or was it something else?
It was tuberculosis.
And at the time, there was no cure. That's why. Okay, got it.
Exactly. So yeah, it was a little tricky. Obviously, I mean, he got very sick. He couldn't do much about it, right? But yeah, so G.H. Hardy was visiting the hospital, and the story goes that Ramanujan saw the number. He said, well, G.H. Hardy told him that the number of his taxi cab was 1729. Yeah. And then Ramanujan said that that's the smallest number that can be added using cubes, right?
Okay.
So do you understand what I mean?
The smallest number that could, yes. Okay.
So it would be 1 cubed plus 12 cubed and 9 cubed plus 10 cubed.
Got it.
So with
exactly.
2 different forms.
And that's the lowest number we can get from actually adding
two.
Got it.
Yeah.
Perfect. And it's incredible to see how much work someone was able to accomplish at such a young age. And so sad to see what was left in that life if maybe the world was at a point where it would have adhered to his cultural needs.
And some people even say that when you look at Ramanujan's work without the proofs, it's like seeing familiar objects without knowing where they came from, you know?
And that was another big problem, wasn't it? The whole proof part.
Yeah, I mean, Ramanujan didn't come there to learn proofs. He came to get published.
And that was one thing I respected him a lot for. He stayed true to his belief, and he always said that God gave him these equations,
Exactly,
actually.
Right, that's where we get this one, right? Where his god or goddess wrote it on his tongue.
Yeah,
right? So,
and when he was presenting that to the fellows at Cambridge, they strictly scrutinized it by saying, you don't have any proof behind this. How did you get to this? Yet he stayed staple in the fact that it came from his God.
Yeah.
I find that very respectable.
Yeah, he knew.
Yeah.
You know?
And Ramanujan is a very wide-held story. I think most people will know it, but we're going to transition into someone that I think many people will not know. Maybe for sure the scientific community, but for you guys watching that are getting interested into these podcasts, we're going to talk about the astrophysicist Subramanian Chandrasekhar. Chandrasekhar was an astrophysicist, and at the time, Einstein's relativity had just come out.
Right.
And in Einstein's relativity, one of the results is actually a black hole. So what Chandrasekhar and the whole scientific community were wondering at the time was, in astrophysics, we had the idea of a white star, where the inward chemical reactions would collapse due to the force of gravity overwhelming them into a white dwarf star.
And so this is when the star is dying, correct?
Yeah, so the chemical reactions become less and less, and then the inward gravitational pressure compressed them into a white star. But scientists at the time wondered what happened if the mass was actually greater than the white dwarf. White dwarf, not white star, sorry about that. So the gravitational force of, let's say, the sun, right? We can use that as an example, would overwhelm the chemical pressure. The only thing sustaining a white dwarf is electron degeneracy pressure, which just means two electrons cannot live in the same state, so same quantum state. It's Pauli's exclusion principle. So that energy alone and that exclusion from each other's states holds that white dwarf in place from incoming gravity.
Got it, okay.
What Chandrasekhar had in mind is, can there be a certain amount of mass that overwhelms that electron degeneracy pressure? And turns out that there is a limit to it. 1.4 solar masses.
And so that's what Chandrasekhar found.
Yeah, Chandrasekhar found that limit, which is 1.4 times the mass of our sun or solar masses.
Okay.
Wow. And you might be wondering, what happens past that? What happens when we get to a point past 1.4 solar masses? And it's really incredible. So the electron degeneracy pressure, the gravity becomes too much for it, and it compresses to something called a neutron star, where the neutron degeneracy pressure actually withholds the external force of gravity. And it was Oppenheimer and two other scientists, which I forgot their name right now. But the gravity overwhelms the neutron degeneracy pressure, and that's when we get a black hole. The event horizon forms.
Oh, it's incredible.
And it goes down to infinity. Yeah, so more on his immigration to the States. He was he was part of colonial Britain, the British India. And he moved to Britain, I think, first, and then to the United States, to the University of Chicago, where he faced heavy scrutiny, a lot of racism. Same thing that Ramanujan faced, a lot of cultural differences.
And we see a pattern here. You know, when someone immigrates in times like those, and even times right now, right? They face a lot of hatred.
Of course,
you know?
a lot of hate towards them.
Yeah, racism. You know?
Because of the differences
Right.
between two people.
Right.
Someone can't look at another person and accept them as different.
And well, obviously there's no good part about it, but the best part is that they prove everyone wrong, every hater wrong.
Yeah.
You know,
Yeah.
as they say.
That's what inspires me about these two men. They were able to show, well, he actually got Royal Fellowship at Cambridge. Ramanujan was able to
right on his deathbed.
I know, and he was able to receive the news before his death, which is actually something that most scientists don't get the luxury of, understanding that their findings were big before they die. So Chandrasekhar faced a lot of racism within the United States, a lot of cultural differences. In the University of Chicago, he was able to find some sort of a haven, but he still faced that sort of racism. However, in the University of Chicago, he was able to expand his sort of scientific understanding.
Right.
Then when it came time for him to publish his Chandrasekhar limit, he faced a heavy amount of backlash. Whether it was because of racism, whether it was because of scientific disputes, we can't know for sure. However, one of his biggest contradictors was Sir Eddington, the man who proved Einstein's relativity.
Right.
That was probably more due to scientific dispute, because Sir Arthur Eddington actually saw physics as more of a, how do I put this? He saw it as more realistic. He thought the idea of a black hole or a white dwarf collapsing was too grand, was too outrageous to even think of.
Right.
He saw it more in a realistic view. So he heavily opposed Chandrasekhar.
Yeah.
And then when Chandrasekhar released his paper, again, still heavy scrutiny until it was scientifically proven that Chandrasekhar was right.
That's incredible.
He overcame the scientific disputes.
Yeah.
I think for me, the main lesson for us, me and you, we both come from immigrant parents.
Right.
That's an inspiration for me every day.
And so you're from Colombia, right?
Yeah, Colombia and Poland, both ways. So my dad came from Fusagasugá, small town, in Colombia. My grandpa went to go get his master's in the University of Kentucky and brought my dad, along with my aunt, here to the United States, and then later to Miami, where we set ground here.
Oh.
And my mom went from Poland, small town again, Biskupiec, all the way to Miami. And they're an inspiration to me every day.
Of course. Yeah.
The struggles they faced coming in, the struggles they faced getting citizenship, the amount of discrimination in job markets and whatever.
Yeah, and I fully agree with you. I mean, my parents come from
Argentina.
Yeah, Argentina, Córdoba.
Okay.
Yeah, that's the Providence, right? And then in a small town, Rio Ceballos.
So both from Argentina.
Yeah, both of them, right? And I mean, it's rough when you get here. You know, you face a lot of backlash. Well, just it's rough.
It's rough, of course. In the job market, also making friends. Learning the language. My mom knows 4 languages. My dad also knows 3. So it's incredible how they were able to learn an extra language. I only know 1.5 if we're including Spanish. I know my Spanish pretty well, but still, it's broken.
Right.
And the fact they were able to struggle to provide a better life for me every day shows me how much effort I need to put in order to set up a better life for myself and my family, to give back to them what they gave to me.
Yeah, I fully agree with you. Yeah.
I think that's a lesson taught a lot with an immigrant family, where they gave you have the back of your whole family bringing you over here, and you need to do something.
Exactly. They give you everything you can,
And I'm motivated to do that.
Exactly, yeah.
I don't know about how you feel.
Yeah, I mean, it's the same way for me. I mean, they went through all these struggles, right? For me not to do something amazing, it'd be a waste, So it's the motivation that drives me every day.
I'm glad we had this podcast. Right. I think this is one of my favorite ones. Yeah. Talking about this. I mean, these two are some of my idols. So this is what I want to get into, and talking about 2 of my favorite people.
Right.
My mom and dad, and Ramanujan and Chandrasekhar.
Yeah.
It was a great podcast. Thank you so much,
Nicholas. All right. Thank you so much. Yeah.
And thank you so much for our listeners today. We had a great time, and we hope to see you next time. This is our goodbye from iCast.
Thank you very much.
Bye.